The Arctic is melting. And as it melts, species that have evolved to these freezing temperatures are facing a race against their own biology. You've heard of polar bears and belugas, but let me introduce you to the unsung heroes of the North, the Arctic cod. Arctic cod feed on plankton and in turn are eaten by everything else. Whales, seals, seabirds, even other fish species. They are the Codfather of Arctic ecosystems. And without them, life in the North just wouldn't exist as we know it. Now, their bow ties don't help them survive, but their gill rakers, these small comb-like structures on the inside of their gills, do. It's actually how they feed. When young, their gill rakers are quite dense in order to capture small baby plankton from the water that flows over their gills. But as they get bigger and move to deeper waters, these gill rakers space out to capture larger, more mature plankton. But here's the problem. Climate change is pushing Arctic plankton out, and Arctic cod may need to adapt their gill rakers in order to survive on new or different prey. And that's where my research comes in. So, genes are like the instructions that tell your body what to do. I'm trying to identify the genes responsible for gill raker growth in Arctic cod to see if these genes and in turn their gill rakers can adapt. First, I will take genes known to instruct gill raker growth in other fish species, and then I will compare that to the entire Arctic cod genome to see if there are any matches. Once I have my matches, I will measure how much the gene is expressed in Arctic cod samples using a technique called quantitative polymerase chain reaction, also known as qPCR. Now, this sounds scary, but think back to when you were a teenager and you were in your awkward, pimply growth phase. Your growth genes were turned on way more than they are now as an adult. Your genes are always there, but it's a bit like a light dimmer. They can be turned up, down, on, or off. So, for example, if qPCR shows me that the growth gene in the gill rakers is turned on more brightly, this will mean that the gene expression is higher in that individual and likely that fish's gill rakers are more dense. By comparing gene expression across age groups and habitats, this will help me determine when and if gill rakers are adaptable, which helps inform conservation strategies by allowing me to identify which factors make them most vulnerable to changing prey. But this isn't just about the conservation of one fish species, as Arctic cod are crucial for the Arctic ecosystem, which itself drives global nutrient patterns. So, if we lose Arctic cod, this would destabilize northern food webs, destabilize fisheries, harm Canadian economies and the communities, which are many, that rely on them. Factors which ultimately affect us all. Thank you.